Thanks, everybody. Very happy to be here. We have a lot of content to get through in a relatively short amount of time. So unfortunately, we won't have time for questions, but I will be hanging out here. I'll also be at the Stockholm show, so hopefully we'll get a chance to hang out and talk a little bit more about Gen AI. So we're going to talk briefly about the current impact of Gen AI. We're going to look at some challenges that a lot of organizations are kind of facing right now when it comes to adopting this technology. We'll look at some adoption strategies, some things that, especially as leaders, we can take away and hopefully kind of implement with our teams. We'll look at a few interesting SDLC agent integration use cases. A lot of what you're going to learn in the meat of this session is applicable to both coding assistants like Cursor and Copilot and things, and also agents when you build prompts for agents. So kind of keep that in mind when you're looking at some of these use cases. We're going to go over some prompting best practices and some high impact use cases. This was part of a study. This was a guide that we actually built based on interviews and surveying developers to try to figure out what some of these really high-value use cases were. So it's all kind of based on data, and I'll explain kind of briefly that study methodology, and then we'll go into some next steps. Okay, so Gen AI is impacting development, right? We don't know necessarily if it's good or bad yet, but we look at some of these industry reports, like for instance, the Dora report, that came out in now April of this year, which saw modest but positively leaning results when we looked at industry averages. Okay, so we saw that 25% increase in overall AI adoption was associated with a 7.5% increase in documentation quality. Okay, good. A 3.4% increase in code quality. Modest, but at least not trending in the opposite direction, right? 3.1% increase in code review speed, 1.3% increase in overall approval speed, and a 1.8 decrease in code complexity. Okay, seems fairly innocuous until we break it down by company. These are per company metrics looking at the Dora metric for change failure rate. So what you're seeing here on the top are companies who actually increase their change failure rate by 2%, which doesn't sound like a lot until you realize that the industry benchmark for CFR is 4%. So that means 50% more defects than the industry benchmark. But then you also have these companies on the bottom who have decreased the amount of defects that they're shipping, so 50% less decreases. We can't trust the industry average data that we're seeing right now. But what we can do is work really hard to be the type of culture and company that's on the top of this graph, okay, and measure and do our best to be there. It's just not evenly distributed right now. Some organizations are seeing very positive impacts to KPIs. Others are struggling with overall adoption and even seeing these negative impacts that we saw. And we really wanted to set out and kind of discover the differences. What is the difference and what can we do to help companies improve? At DX, we measure developer experience and productivity. So we have a nice wide view of how a lot of companies are doing. Obviously, we're looking at correlating this now, AI usage to these foundational productivity and experience metrics. But we also want to be able to provide materials and education that can help people move those metrics in the right direction. One of the biggest indicators that we found, though, in talking to companies that are struggling is that there's just a lack of enablement and overall education on best practices and use cases. Not only do we have to provide training for our engineers, we have to give them time to learn and experiment. This is new tech, or you can't just turn it on and expect everything to just work great, right? There's actually a lot of nuance to the way that this technology works. We've also found that some companies just don't really know what to measure or how to measure. And of course, that's something that DX is very good at. Some overall adoption strategies, some things to think about beyond, I would say, code generation. Integrate across the SDLC. Who's familiar with Ellie Goldratt? Theory of constraints? Okay, a few of you. An hour spent and saved on something that's not the bottleneck is worthless, okay? And code generation has not necessarily been the bottleneck. So we need to seek out other areas of the SDLC where we have true bottlenecks, where we can apply agents and this technology to try to increase automation and improve throughput. We want to unblock usage as much as possible. I hear a lot of companies saying, well, I'd love to use Cursor, but we can't because of data residency. Get creative, right? There are ways to self-host these models. There are ways to run these models on private infrastructure. Think around some of these problems. We want to evangelize the metrics. When teams are doing well with this, we should share that with the organization. When teams have had a successful experiment, those teams should be allowed to teach the rest of the organization what they've done. We need to reduce the fear of AI. Okay? This technology is not ready to replace jobs. There was already the vanguard of companies that tried this and they failed and they're clawing it back and no one wants to work for them now because they fired all their engineers. Okay? So we need to move into the next phase. We are seeing 8% improvements, 10% improvements. Zapier is hiring like crazy right now because they know that every new engineer they put in will be more productive because of a result of this technology. That's the way that we need to be thinking about this, is something that can augment our teams. That said, AI is probably not coming for your job, but somebody really good at AI might take your job. Okay, so it behooves us all to learn about how this technology works and get better at it. And we need to tie this to employee success. And of course, all this means we need to establish compliance and trust in the outputs that are being created by this technology, which we can do through better testing, better quality engineering, and really just understanding where these LLMs make mistakes and how we can move around them. And we'll talk about some strategies for that. But first, let's talk about some kind of fun use cases that we're seeing. Morgan Stanley, there's a great write-up in this in the Wall Street Journal and also Business Insider. They have a lot of legacy code, including mainframe code, including, and I hate to say it because I'm an old Perl head, I've been writing code since the 90s, but Perl legacy code, COBOL legacy code, mainframe natural language. And they built an agent that goes through, grabs context, and builds developer specifications to allow developers to help modernize the code, right? So it's not a full end-to-end solution. Again, we're not there yet, but it reads legacy code and creates developer specs, and they're saving about 300,000 hours annually by just eliminating the reverse engineering step and understanding how that legacy code works. Fair has built an automated code review system that they trigger off of a pull request. It pulls context and surrounding code. Documentation provides pull request comments right as a first pass code review. And they're completing about 3,000 reviews of relatively low risk stuff right now a week with that agent. Canva's using this for PRD generation. So they actually have project managers that are able to just say, this is what I want to change in the system. And it generates very engineering friendly specifications, which is often a problem, right? Getting a good clean handoff from project into specs that developers can actually understand. It has MCP servers that expose context and documentation, connects to Jira, and even creates mockups in Figma. Spotify is handling 90% of their incidents right now using agents that understand SRE runbooks. They can detect problems and monitor for alerts, and then they can suggest runbook steps directly in SRE channels in Slack, handling 90% of the incidents at Spotify. In fact, they're starting to call their new AI-enabled or AI-native SDLC like the Spotify 2.0 model. That's kind of what we're moving into. Okay, let's get into the meat of this thing. So first of all, again, what we wanted to do was we wanted to seek out these companies that were at the top of that graph I showed you. We wanted to figure out what they were doing well and how we could help other people kind of move to that state. So we wanted to determine the highest value prompting practices, best practices, and also high value use cases. And we used data to do this. So we interviewed a lot of S-level leaders from these companies who were doing well and just asked them, what are you enabling your engineers to do? What are some of the prompting best practices and things like that you're reflecting that engineers become reflexive in their use of? And where we found overlap in those interviews, we put them in this guide. Then we also surveyed developers directly. We wanted to look for developers that were saving at least an hour a week. By the way, the average time savings has moved up to about 3.5 hours a week right now. Again, not the bottleneck, because we're losing hours and hours to meetings and context switching and all kinds of other stuff, but time is being saved. And so we surveyed these developers and found out, we asked them to stack rank. What are your top 5 use cases for AI that you're getting really reflexive about? And we created sort of a top 10 list that went in this guide. So this is all sort of data driven. Now, if you'd like a copy of this guide, totally free. It's like 65-page PDF. You can download it here. And it goes through the same practices and use cases that we're going to go through in this workshop. I do need to move on. If you don't get a chance to capture it, though, don't worry. I will show this slide again at the end of the session, so you'll have another opportunity. If you miss that opportunity, come talk to me, and I'll show you where you can get the guide. I am proud to say that this guide has become required reading now for a number of engineering organizations. So we're hoping that it's been very helpful for folks. Okay, so let's talk about some prompting best practices first. Meta prompting. All right, this is the idea of actually paying a lot of attention to the structure of the way that you put together your prompt. These are still just probabilistic motors, they're machines. They do way better when the context that's provided to them and the prompt that's provided to them is really well structured, when you give them a lot of clues about how you want them to execute their workflow, and then moreover, the way that you want them to structure their output, right? So you can just go in and put a sort of a lazy prompt and go back and forth and sort of tune the thing, or you can be sort of thoughtful about the way that you want the model to execute its work from the very beginning, and you'll save yourself some time in that back and forth. So you can see here, this is a very simple example. We're saying, instead of just saying, fix this Spring Boot error, and then giving it the error, we're saying debug the following Spring Boot error, paste the error details in, and then we're giving it some dash points. We're saying, okay, identify and explain the root cause. That's the first part of your workflow. Then provide a fixed version of the problematic code, and then suggest best practices to prevent similar issues in the future. Now, I could end there, and it might be able to infer the kind of output that I want if I just stop the prompt there, but it will definitely give me the kind of output that I want if I take this one step further and be very explicit about how I want this output to look. So I'm saying, give me number 1, error message and stack trace, summarize. Number 2, a root cause analysis. Number 3, fixed code with comments. And number 4, give me some preventative measures. And then it will definitely output the way that I want it to when it goes forward. And this can work well for assistants and also work well for agents. So meta prompting, this came up number 1 overwhelmingly from the people that we interviewed. Now this one though, I mentioned that I've been writing code professionally since the late 90s. I wrote my first bit of code in the 80s on an old Tandy Radio Shack model. It was GW Basic. I'm on this journey too, okay? But this is one of the use cases that I have become really reflexive about and has absolutely changed the way that I work. And this is called recursive prompting or prompt chaining. Now, at a high level, this just means having one kind of conversation with a model, taking that conversation transcript, passing it into a different kind of model to have a different type of output, like a specification, and then maybe even taking that specification and asking another model to scaffold code. And what it's really good for is having brainstorming sessions, right? So you can see here in this example, this is just a silly example. I'm saying I'm a mobile developer, you're a senior React Native architect, and this sentence has to appear. Let's have a brainstorming session where you ask me one question at a time about the following requirements. And then I'm going on to say that I have 2 separate iOS and Android repos, and I want to convert them all into React Native. And this isn't about whether you like React Native or not, it's just an example. But the point is that the bot will then go on to ask me one question at a time about the problem that I'm trying to solve. We'll have a very comprehensive conversation. It's almost like a 2-way rubber ducking kind of session, where it's like I'm saying what I want to do, but the bot is actually asking me questions very comprehensively. Now, I don't know about you, but I always forget stuff in the planning phase whenever I'm sitting down. Always. There's some gap somewhere, something I didn't consider. This has been instrumental for helping me make sure that from the very beginning, I get the right type of spec. So you're seeing it's like asking me, okay, number 1, what are the main features and functionalities of the existing mobile app? And then it's asking me some more questions. And these are all word for word came out of the example when I was generating it. Final question for now. Are you targeting just phones, or does the app need to support tablets, or other form factors, right? So you get the point. I could then take that full conversation and feed it some meta prompting as well and say, okay, now take this whole chat transcript and come up with a step-by-step specification for how to implement this. Give me a step number, a summary of converting the feature, an example prompt, and even maybe example unit tests for what I'm trying to do, and then give it the full transcript from before. Then you'll end up with a spec. And you could stop there and hand that spec to a developer and go on, or you could pass that into a code generating model and ask it to scaffold out your project. Now, I used to have to do this pretty manually, and you still kind of do in like Cursor and Claude Code and some of the other solutions. But Amazon Kiro, I got a chance to try the public preview for that. Anybody else tried Kiro yet from Amazon? It's really cool. And that's a first-class citizen. So when you start a new project, it actually takes you through this whole brainstorming workflow first. I was very pleased to see that. Okay, one-shot or few-shot prompting, similar to meta prompting, except in this case, we're actually providing example code, right? So beyond just coming up with a particular structure, we're actually saying, okay, here's an example of the code that I want you to produce, right? Stylistically and semantically. So as opposed to a lazy shot prompt, which is just nothing, just saying, hey, build this for me. We're actually saying, okay, here's an example of a structured REST API design. Then I'm giving it a simple REST controller annotation or request mapping. Then I'm saying, okay, now generate a hello controller that uses a hello service layer, that returns a data transfer object instead of plain text and follows RESTful semantics, right? So you see, this is kind of like meta prompting, except we're very specifically saying this is the way that I want you to write the code when you output. All right, I mentioned before, we're going to look at some things to make these models behave better. One of them is having a good feedback loop for keeping your system prompt up to date. In Cursor, these are called Cursor rules. In Claude, this is like your agent markdown, but there's various versions of this. The idea is that you want to find the one that extends to as many people on your team as possible, right? For a couple of reasons. First of all, it helps everybody to have a system prompt that's up to date and tuned well for the way that you want it to behave, as opposed to just helping you. I've definitely seen engineers who keep like a local rule file, and certainly some of these solutions have markdown that'll let you do the same thing. That increases your context window, and it doesn't help the whole organization. So you want to come up with a feedback loop where when the model does something it's not supposed to do, you have a way of providing that feedback to somebody who gatekeeps the system prompt and can keep that up to date from everybody. I've seen people put this in source control. For like well-decentralized organizations, just have a system prompt that's in source control and everybody can kind of contribute to it and it has its own version control. Any of that's fine, whatever works for your culture. But the point is do this, right? Build this feedback loop. So you can see the example here. It's basically saying, hey, you've been observed making the following errors. You're providing outdated Spring Boot versions. You're suggesting or using deprecated methods. You're returning snippets that have syntax errors. So going forward, always provide code snippets that are Spring Boot 3 or greater in this case. Verify that you're not using deprecated methods, double check that any code snippets are syntactically valid, and then I'm even giving it specific output that I want. So I'm saying, okay, when you're responding, give relevant explanations of your code choices and other bits of meta prompting there, right? So a good meta prompt inside of a system prompt, one that you keep up to date, because it can get stale as rules change within the organization. It's just mostly important to have a feedback loop to keep it up to date and have a way to provide that feedback to whoever's keeping it up to date. Okay. Multi-model adversarial engineering. This was one of the first ones. This was, can we actually have multiple models evaluate each other's solutions to see which one they think is better? The nice thing is, at least right here in 2025, these models have absolutely no ego about what they're doing. They will totally admit when they've done something wrong. Although I have, your mileage may vary, but this is when I've given this workshop a few times now, and I have had people say like, hey, if you tell like Copilot that this is a ChatGPT solution, it's going to maybe go, like the marketing people might have gotten to it a little bit and they're like guarding their own brand. So I don't know, it may work better if you just don't mention where the solution came from, but you get the idea, right? We're saying like, here's a solution from ChatGPT, evaluate its correctness, note any potential improvements. We're feeding that to Copilot. Then we're doing the opposite thing with ChatGPT. We're saying, well, here's what Copilot said. We're already moving in, like this is very manual, but we're moving into architectural solutions for this already with things like agent to agent and AI gateways. So, and some of these solutions too, like the quote unquote reasoning models are already doing some of this work behind the scenes as well. But just something to be aware of, that if you're not quite sure, you want to make sure you're driving the best solution and you already have multiple service, like all of us are doing multi-solution because everything's moving so quickly, we can't really land on one anyway. You may as well just go and have the models test each other and see which ones they think are the best solution. Okay, multi-context prompting. I spoke to one engineering leader who said that when they use whisper or voice to text or just click the microphone button in the solution, that their engineers are 30% faster, right? This is almost like ultimate vibe coding because you're like talking to it and things are just like appearing, right? The point is, don't be afraid to move beyond text with these models, right? Think about interacting with voice. Certainly think about uploading pictures. They're getting better and better at understanding pictures. I was talking to a company who's already set up an MCP loop between their browser tools and like the backend. So it's like if something fails in the front end, it literally just automatically screen caps developer tools, sends it into the agent so that it can understand the browser error just by reading the screenshot. I've been doing that too with front end work. This is a silly example here where we have a decision tree. It's what do I do today? Am I indoors and I'm outdoors? And if I'm alone, I should read a book. And if I'm in a group and indoors, I should play a board game. And if I'm outside and alone, I should take a run. And if I'm in a group, I should go play pickleball. That's a big thing in the US right now. But the point is, like, instead of trying to type out this full decision tree, don't be afraid to just upload a picture. These models are really getting better at this. So think about different contexts in which you can engage the model. All right, so beyond the system prompt, we also have another lever here we can pull for making the model more or less deterministic, right? This is called altering the temperature of the model, right? Temperature is heat, is entropy, is randomness. That's where you connect the dots there. The thing is, when these models go and predict like the next token to give you, they're not just saying, okay, this is the token. There's a big matrix of them. And then the randomness that's applied for picking the token from that matrix is the temperature. So you actually have some control over whether it's going to pick the first one or whether it might pick one that's later in the list. It's kind of a crude way of explaining it, but it's sort of how it works. The temperature moves between the numbers 0 and 1. So 0.0001 would be considered a low temperature. Don't use 0 and 1. Weird stuff happens when you set those absolutes. But you want to put stuff in the middle. And 0.09 would be considered, 0.9 would be considered like a high temperature. So you can see, like, if you combine a system prompt with a good deterministic setting for the agent or even for the assistant, and you can experiment with this, by the way, like anyone using LM Studio or Olama or Docker Model Runner, highly recommend like playing with these things. You can run a lot of open source models like right on like a decent laptop or even a gaming machine, and get out some interesting stuff. But you can always set the temperature on these, and you can see what's happening. I have a low temperature in this example here on the right, where I'm saying create a JavaScript method to render a gradient of colors from blue to red. And I'm not sure how well you can see that code, but character for character, it's exactly the same when I set a low temperature. So I ask it that same prompt twice. I get exactly the same output both times with a low temperature. Now I crank that temperature up to 0.9 and look at this. They're both valid solutions for the same problem. But you can see here on the left, it's starting with like an HTML block and it's using some CSS to do the rendering. Whereas on the right, it's taken a wildly different approach. It's just using JavaScript. It's pulled in a canvas object and is manipulating that. Okay, so again, both of these are valid, right? But these are very, very different depending on the temperature that I've given it. So you can now see where like system prompt and temperature working together can give you some more like determinism, some more like predictable behavior from these models. All right, so how about some high impact use cases then? So I mentioned that really just came from interviews, figuring out what SVPs are doing when they've been rolling this stuff out successfully. This one's way more straightforward. It was just speak to engineers that are already saving time with this stuff. Give me your top 5 use cases that you're using right now that you think saves you the most time, and we turned it into a top 10 list. Now, we're going to go through each of these, so I'm not going to go through all of these right now, but number 1 was stack trace analysis. All right, interpretive use case, not even a generative use case. And another one that I've had to learn to be more reflexive about. I'm an old school Java developer. I was doing J2EE stuff. I'm used to 100-line stack traces that I have to go line by line and try to figure out what's wrong. And now if you like put some of these things in agent mode, like cursor, for instance, and the build fails, it's already doing this for you. Like it's already interpreting this. It will save you a lot of time. Like it's usually pretty right. So you can see here this example. This is just one where I had a build fail and I asked it to analyze the stack trace. And look what it did. It found it, oh, you're missing dependencies, and here are the dependencies that you're missing. And by the way, this is a Gradle Java project, so here's what you should update in build.gradle. And it's giving me some clues as to make sure that those dependencies are going to be available. So the next time you find yourself kind of like, oh, the build failed, let me go through, figure out what's wrong. Give it to the agent and see what it does. Give it to the assistant and see what it does. I know that this is hard sometimes because like we like solving puzzles, like we like figuring out problems. This is like why we became engineers, right? But we also have to start asking ourselves philosophically, what is toil now, right? And if toil is something that the agent can do accurately for us that saves us time, it's our responsibility to use it that way, right? Because we have it, right? So I know it's tough, but this one actually works really well. This is another one that I've tried to become more reflexive in. Refactoring existing code. Yeah, sure. Why not? You've got maybe legacy code, or you have code that was written by another engineer that you want to make more efficient or more readable. And that's effectively what I've done here. Now, silly example, I'm just having it calculate a limit up to a certain point and the sum of that limit. So I'm like, okay, if I put in 3, I wanted to add 1 plus 2 plus 3, it should spit out 6. Great. But then I ask it to improve it for readability and efficiency, and look what it does. It reminds me that I've got this great in-stream library in Java, and I could be using that instead of creating a for loop. Now I've got one line of code, right? As long as you know what an in-stream is, it makes the code a little more readable. All right, mid-loop generation. So I mentioned before that like it's a cool brainstorming workflow to go from like conversation to spec to scaffolding code. Oftentimes that scaffolding will give you a function layout as well. Sometimes it'll just start filling in the functions for you too. But the next time that you've got to write something that's at least fairly boilerplate, right? Think about just, well, could I just write the function header and maybe give a little comment about what this function is supposed to do and allow the bot to just fill in the middle? Like, I already know what I want the function to do, right? So maybe I can have a suggestion from the agent. It'll fill it out. It'll save me some time. I can always go back and tweak anything I don't like, right? But it is another one to kind of try to get reflexive about, especially when you're doing something that's like quasi-generic, like in that case, generating a Fibonacci sequence. Why not? And it does a pretty good job. Good old computer science 101 Fibonacci sequence. And there it is, calculating that for me. Okay, controversial topic here, test case generation. But it came up in the survey. It's just the data. I'm just reporting on the data. Don't shoot the messenger. But honestly, this has become like a first-class citizen in some of these solutions now. Like, for instance, Copilot's had this for a while, where it's just like generate test cases based on this. Look, with plenty of exceptions, this is not always our favorite thing to do, right? We want to write the code. We want to write the functionality. We need the tests. Don't get me wrong. We can't skip them. We got to have them, right? I mean, that's how we keep our code working well. We especially need them now when we're going to be generating some code with AI, and we want to be able to trust the outputs that we're putting into production. But again, not always our most favorite thing to do, right? So see what the assistant does in terms of writing unit test cases. You can even, and I've experimented with this one using front-end languages too that use like Jest. You can even say like, take this class and give it 90% code coverage, right? Not even generate the unit tests. Here's how many of the unit tests I need you to generate till you get this coverage. It'll do it. It'll go into a loop. It'll start generating tests. It'll run Jest in coverage mode. It'll spit out the output, see how close it is. It'll read the output and be like, oh, I needed 90%. I'm at 85. I better generate some more tests. So an interesting thing to experiment with. Okay, learning new techniques came up on this list as well. Yeah, I mean, the thing can sort of understand the code in front of you, and you can ask it some questions about trying to learn a new thing. And this isn't really any different than what we've been doing for a while anyway, which is like going to Stack Overflow or going to Google or whatever. It's really the same thing, just a little bit faster data retrieval, kind of meeting us where we're at without having to go to a browser. But we're saying in this case, okay, I've got 5 years of experience writing Java and Spring. Great, I've given it some context about what I know. Show me how to create a Java 24 virtual thread in Spring. Kind of new thing in 24. And it's doing it. It's okay. Well, to create a virtual thread, you need to use executor's new virtual thread per task executor. And it's giving me a little bit more context about that. It's even giving me some example code. And this is here for me at like 3 o'clock in the morning if the mood strikes me, right? I don't have to wait necessarily to get the answers that I want. And it also understands the context of the code in front of me. Now, I got a question a lot with this one. People ask me, but is that learning, if you just let the AI do it for you? And it's a valid question, I think. But it's also the same question as is going to Stack Overflow learning when I'm just copying that in and trying to do something from that, right? That's on you, right? That's your responsibility. Whether you want to just sort of take whatever the agent gives you and go on autopilot, or you actually want to take the time to explain what's happening and learn from it, right? You have that choice, and you've had that choice long before AI, right? I think there's always people who will be happy to hit the easy button, and always more curious people who want to understand what's going on. That tends to be this crowd, right? We're engineers. We like to understand what's going on. So take the time to learn. Nothing's stopping you from doing that, right? And the agent can be a really great research assistant. Okay, I love this one. I'm often doing this like in my office, and I'll point on Zoom for effect. I'm like, my Mastering Regular Expressions book is right over there on my shelf, and I haven't had to touch it in a year, which is true. Because if you have something that you're not doing every day, and you kind of forget, oh, what was this wild card? Or how did I do this like pattern match? Generating regexes with these things is like pretty awesome, right? And it knows how to do it in most mainstream languages, and it does a pretty good job. So here I'm giving it like some SLF for J output, and I'm saying, all right, create a regex that'll parse timestamps, usernames, IP addresses, user actions, and transaction IDs from log data in this following format. And it does it. It gives it to me. And it creates a pattern object for me to compile the regex, and it creates a matcher object so I can actually use it in line in my code. If you're comfortable either creating like a system prompt or giving these things access to schema, they actually do a pretty good job like traversing schema, understanding foreign keys, and generating SQL statements too, right? Again, if it's just not a thing that you do every day, this can be really helpful. Code documentation. Yeah, whether you're generating ASCII doc or LaTeX markdown or GitHub markdown, or just want more comments in line in the code because you didn't feel like writing them when you were writing the code, right? Lots of ways that the agents and assistants can help us with documentation. Because again, with plenty of exceptions, this is not a thing we always love to do, right? Oftentimes we're in the flow and we're doing great. We're excellent flow state. Everyone's leaving us alone and we've got like focused work. And then it's like, oh, I have to document this thing now so the next person can read it, right? And actually, again, these things are pretty good at interpreting. They're still better at interpreting than they are generating. And so to be able to generate inline comments or create ASCII docs or even have agents now, I'm seeing a fair amount of this where you'll have an agent trigger off of a pull request and then it'll go and gather some context. It'll look at the code diff. It'll look at the surrounding code. It'll update documentation or at least put a draft documentation in front of you that you can say, yeah, that basically looks right, and then send it on its way. It can save you a lot of time here too. So I'm not surprised to see this come up. Okay, brainstorming and planning. I know we already covered this in the recursive prompting section, but it also came up in the survey, right? So I had engineers who also answered that they felt like this was a very high value use case for them. So just a different example, hopefully reinforcing the same point. In this case, I've got a totally different problem, and I'm saying, I am a product manager and you're a senior software architect. Let's have a brainstorming session where you ask me one question at a time about these requirements. That has to be in there again. And then come up with a specification that I can hand to a software developer. In this case, I'm saying I want to design an app that'll create an Elasticsearch index for a large table stored somewhere in Cassandra. Help me design a bulletproof zero-loss system to do this. This is definitely one of those things where I usually forget something in the planning phase because there's so much to designing a zero-loss bulletproof data system. But look what it's doing. Question number 1, are we optimizing for full text search, fast lookups, analytics, or something else? Will the data in Cassandra be static, append only, or frequently updated? How large is the data set? Number of rows, data volume, expected growth? These are definitely the questions that I would be asking myself if I was going through a planning phase, right? So again, really nice comprehensive way of getting that early planning, kind of just right and bulletproof. Okay, we talked about this a bit as a second thing that we can do, scaffolding out initial code. Yeah, I mean, sometimes just getting started is hard. It doesn't have to be a perfect scaffold. But like putting out, okay, these are my base classes and this is how I want to lay out my project and all this kind of stuff, that can take time. And we get too nitpicky sometimes, and oftentimes it's just a decision needs to be made. And then we can just start flowing and coding after that point and go, fix whatever needs to be fixed later. So I'm saying create a code outline for a Java app that'll listen on a Kafka topic, create a multicast pattern to 3 different endpoints. So good old EIPs, Postgres, RESTful post endpoint, and an SMTP endpoint. Great. And look what it did. It structured out my subscriber class for Kafka. There it is, Kafka Consumer Service. It created 3 producer endpoints with Postgres service, REST service, email service, created app config. I said I wanted it to be Java. I didn't specify whether I'd be using Maven or Gradle, so it actually gave me options for both. It's like, here's a POM XML if you want to use Maven, here's a build Gradle if you want to use Gradle, and I can go from there. Okay, now I kind of lose that initial paralysis at the beginning. Similar to learning new techniques, explaining code. Yeah, sure. I mean, explain the purpose of each annotation in the Spring Boot controller class, and then I give it some code. Maybe this is code that a developer wrote 5 years ago and left. Maybe it's legacy code. Maybe it's just something I haven't seen before or I haven't looked at in a long time. And it's breaking it down for me. It's like, okay, here's each annotation. You got your Spring Boot application. You got your REST controller. You got your get mapping annotation. Then it's reminding me that the Spring Boot application annotation is actually just sugar that's comprised of 3 annotations like configuration, autoconfig, and the component, and going from there. So again, great way of learning new things. It's up to you whether you actually want to learn, but you certainly can with these tools. Okay, so some next steps. First of all, use this guide as a reference for integrating AI into your various workflows. I'll show the PDF again in a moment, and you can come find me. Determine a method for measuring and evaluating GenAI impact, not just utilization metrics, not just, okay, who's using this daily active, weekly active. Like that's okay for understanding like how the tech is sort of proliferating through the culture, but we really want to correlate that utilization to the metrics that actually matter. It's so easy to get caught up in the hype and forget that this is still about developer productivity and developer experience. And so those foundational metrics that have served us well are still very much in play now. So we want to track and measure the adoption and iterate on those best practices and use cases. One more opportunity if you didn't already get a chance to grab this. So how should we measure? What should we be looking at? Well, there's kind of 3 characteristics of metrics that are available to us right now, and we got to use all 3. Because they're all going to tell us different stories, right? We have our telemetry metrics. This is the stuff coming out of the API. So Copilot provides this, Cursor provides this. We helped the Anthropic folks actually build their API, so they have some good metrics as well. They're kind of good for measuring the impact on developer output, like how often stuff is being used, but they don't tell a complete story. Like, for instance, everybody wanted acceptance versus suggest until they realized that you have to click accept in the IDE for the API to actually know about that. So it's not necessarily going to be accurate. Or maybe you accepted the code and then you refactored every line of it, right? So that's also not telling the same story. Maybe it made a suggestion and you just typed, oh, that's a good idea, I'm going to do that. Or maybe you copied and pasted, right? So the API doesn't know about any of that stuff. And we also need to be able to correlate that utilization to what actually matters. The foundational productivity metrics that aren't just telling us what's happening with the AI, they're telling us if it's working or not. So this is where we need experience sampling, the ability to get small bits of data and trap developers in their workflow so that we don't force them out and force them to context switch off to something else. This could be like issuing a PR and having a new checkbox in the PR that says, I used AI to work on this PR, or I enjoyed using AI to work on this PR, or whatever it is. We can get these small bits of data. Not great for collecting large amounts of data at once, though. That all has to be aggregated. We don't want to do a 10-minute survey in every pull request, but we do want to do surveys. We just want to do those periodically. That's this last bit of data here. We want highly effective surveys. A DX, I have a very strict definition of that. We maintain 95% plus participation rates in most of our customer surveys, 90% in all of them, even with thousands of engineers. Yeah, I know. And we do. It's really hard. And if you want to learn about how we do that, I'm always happy to talk about it. But once you get participation rates like that, you can really trust a lot of these qualitative metrics, especially when you cross-reference them to the experience sampling and the telemetry. And so with that in mind, we actually did build the first DX, this is our DX AI measurement framework. We were first to market with this. It took what we already knew from our core 4 metrics, which are comprised of DORA, the space framework, and the DevX metrics, all distilled into a single metric framework. So we're using the same stuff. We're using oppositional dimensions, in this case, the oppositional dimensions of utilization, impact, and cost. And we have a number of prescribed metrics that fall into those dimensions. This is sort of a maturity curve too. Most organizations will start on the left, capturing basic utilization metrics, and then immediately start wondering, okay, well, is this actually working? In which case they'll start moving into these impact metrics that you see here. How is utilization correlated to improving velocity, improving quality within the organization? And then yes, cost. Although I do love to point out that 15 years after the last hype cycle ended in cloud, we still have brand new companies that are telling you they'll help you control your cloud costs. So we'll see how long that takes. On the flip side, I have already heard horror stories about people burning through like $2,000 worth of tokens a day. So we probably do have to do something, but I think it's going to be kind of on the right of this continuum. I had a Q&A slide that came after that and I had to take it out and I probably should have said something. Anyway, thank you. I hope that was helpful.